Hello, everybody. My name is Tyll Hertsens. I'm the editor at InnerFidelity.com, Stereophile's sister website for personal audio and headphones and stuff. And today we're going to be talking about the future of headphones, which is, I think, going to be pretty amazing. But I'm not going to put too many words in anybody's mouth here. I'm going to let these guys talk for themselves. So we're going to start at this end with Paul, and if you guys would go down the line and introduce yourselves and who you are, and then we'll get started with the conversation.
Well, I'm Paul Barton from PSB Speakers, and I'm a new entrance into the headphone business, I think about 5 years now. And I'm very intrigued by the new listening habits of the younger people, and certainly everybody who likes to listen to headphones. And my goal is to try and produce headphones that are comfortable and sonically correct. And you'll hear more about that as we talk.
I'm Jude, and I'm the founder of the forum headfi.org. I think we're still the biggest headphone website on the web. I'm the only one up here other than Tyll that doesn't actually make a headphone, so we just talk a lot about them. And I guess that's what we'll be doing more of today.
I'm Dan Clark, founder of MrSpeakers. We make planar magnetic and now electrostatic headphones. We're a San Diego-based company, and our product is all designed and built in San Diego.
And I'm Nicolas. I'm in charge of product marketing department at Focal. So I'm managing both divisions, be it headphones, home audio, so classic speakers, pro audio and car audio as well. We manufacture drivers and loudspeakers since 37 years now in Saint-Étienne in France.
All right, so this talk is about the future of headphones, and I'm just going to go down the line here again, and would like to hear what you all think the future of headphones is in the semi-near term, the next few years, and then we'll go farther afterwards. Paul?
Well, right now the reproduction of headphones is, compared with what Tyll is going to be talking about later, or probing to get more information on later, using all kinds of processing to create an illusion of virtual reality. A lot of what I'm doing now is trying to refine the art of making a good driver that couples well with the ear, and the transfer function based on much study that has been done on the head transfer function and what kind of target function that you have to design a headphone for. And let me explain. When you listen to music that was recorded to be played back on loudspeakers, there's one component that is not in the equation, and that's the room that you're listening to the speaker in. And a direct radiating loudspeaker that is anechoically flat on axis doesn't have the same response if you look at the total sound power that the speaker has. So when you put on a pair of headphones and listen to music that was recorded to be played back on speakers, when the engineers were mixing that music, they were listening to that music in a room on a pair of direct radiating loudspeakers. When you put on headphones, that's not the case. So you have to compensate, and the challenge is, what compensation do we need to do? And PSB has already earmarked a transfer function which we call room feel, which I incorporate in the headphone, so that when you listen to music on a pair of headphones that was recorded to be played back on speakers, you get the proper balance of the frequency response that you would perceive when those speakers are in a room. And the challenge is, what is that transfer function? And that can only be really achieved by doing lots of study of rooms and the effects that rooms have on loudspeakers, typical direct radiating loudspeakers, and also on people's subjective evaluations, because it's very difficult to plug a wire into somebody's head and measure how subjectively they're enjoying the music. I guess you could put all kinds of things on them to see how their heartbeat is and things like that. So we do a lot of subjective evaluations, trying to correlate that with the transfer functions that we propose are trying to compensate for the required frequency response when you listen to music that was recorded on loudspeaker, with loudspeakers and played back on headphones. And that's the big challenge that I've been focused on over the several years, and definitely as we go forward, I'm very optimistic about, you know, when you put a pair of headphones on your head, the brain is totally confused because it's normally used to hearing delays in this ear based on the sounds and where it's coming from. When you put on a pair of headphones, all of that data that the brain uses is totally gone. And that's what Tyll was referring to when we spoke earlier about the head transfer function. All of these very subtle things, and the brain is extremely adept. One thing I can maybe say to you that you've all experienced, but you're not totally aware of what you just experienced, is when you're listening to somebody who is on a speakerphone, you know, you're talking to them, and can you tell they're on a speakerphone? Why do you know they're on a speakerphone? You hear the reverb in the room.
Direct or reflected.
Right? You hear the echo in the room. When you're in that room, do you hear that echo? And it's because the brain is processing that out. And we're doing that in real time, all the time. And I'm very intrigued on studying all of those things that our brain is doing to try and capitalize on how we can create this virtual reality when we put headphones on. So that's kind of where I'm coming from.
Jude?
I think that we're going to see audiophile headphones. It's going to kind of go the way of hi-fi, right? So hi-fi home theater, you have all these surround technologies and everything else, and the audiophiles haven't really largely adopted that to listen to music. And I think there's still going to be a whole, like Dan at MrSpeakers here, I don't know what Focal is going to do. They're a bigger company. Maybe Focal would be more willing to engage in some of the technologies. Well, we're talking. Should we talk about HRTFs here?
Well, we can certainly get to it, and you can certainly throw it in. And
yeah.
But if I'm looking more in the 3-year time frame at the moment.
Man, I don't know. It's moving pretty quick.
Yeah, it is moving pretty quick.
So yeah, Tyll and I were both at the AES's first headphone technology conference in Aalborg, and it was actually pretty amazing.
Yeah.
But and I think things are moving quicker than some realize. But I think there are two different sort of markets, at least as concerns this room, right? I think a lot of us are going to be perfectly happy. You're right? From an imaging standpoint, it gets, some of us can't listen to headphones, but a lot of us can in terms of being comfortable with the way it images. And I think a lot of the people that are walking through the CanJam area they've accepted it. That's headphone listening. And I do think that's going to go for the long term. I don't think Dan's going out of business because Oculus is going to do something with respect to virtual reality and 3D sound and things like that. There will always, I think, be a market for what he does and what Focal's doing now and what HIFIMAN's doing now, what Paul's doing now, which is making headphones that serve the music, listening to headphones the way we currently do. And I think we're comfortable with it. But then there's this whole other segment, which is the virtual reality, augmented reality thing, which a lot of the conference was about. Mm-hmm. There were no 4 letters strung together in order more there than HRTF,
right.
Head-related transfer function. And that's an exciting field because once you can capture an individual's HRTF, if you capture it perfectly, like Smith pretty much does, Smith Research, headphones have effectively taken a lot of the variables that we deal with loudspeakers completely out of the equation, right? Because no room. It's a controlled environment, one we can factor in for, we kind of know what we're having. And so a company like Smith, once they've captured your HRTF, well, perfectly, really, it's about as convincing as I've heard it, then you can do all sorts of neat things with it. But that's a whole nother place, and I don't think a lot of the people walking through there playing their music are necessarily wanting that for the music listening. It might serve it well, but maybe it'll be like surround sound is for us now. I just don't think there are a whole lot of people in here that are necessarily listening to the music through surround systems at home. as cool as some of them can be, certainly for movies. But anyways, that's how I see it going. I still think there's an audiophile market, and I think with respect to who we are here, we're comfortable listening to headphones. I don't think we're going to all of a sudden become uncomfortable listening to headphones. Those who just don't like them, like my mom's not crazy about headphones, they're just not going to like them. But anyways, that's how I see it going.
So I see a couple different areas that are going to be of interest, and I won't repeat some of that stuff, which I happen to agree with in large part. But in core technologies for headphones, I think we're seeing a really interesting dynamic right now that the base of technology has moved from the majority of headphones being made on dynamic drivers to now there are dynamic drivers, there are planar drivers, there are new electrostatic products that are coming out, and they're coming out in different form factors. We're starting to see hybrid technologies where you get dynamic and planar and dynamic and electrostat put together. People are working on interesting things with AMT drivers. And so the core driver technology and the guts of what are going to make the headphones good, with or without DSP-based or other-based HRTF, is really evolving rapidly. You know, if you look at the quality of sound you get from the headphones, you know, the high-end or the mid-range headphones today, and compare them to what you got 4 or 5 years ago, it's sort of like comparing a Ferrari to a, you know, I don't know, a 1950s big Chevy with a lot of chrome on it. You know, the resolution's increasing, the clarity, the distortion levels are falling, dynamics are improving, frequency extension and linearity are all getting better. And it's all appearing in now new form factors. You know, it's like one of the other companies in the space, Odyssey, came out with a planar magnetic. It's kind of hard to call it an in-ear monitor. It's more like an on-ear monitor. But you know, it's really neat seeing extensions of the technology being moved into new applications. Sure's got an electrostatic earbud. So people are doing, you know, HIFIMAN and we are both working on new planar magnetic or electrostatic technologies, and you know, we've driven the engineering down to the point where we're working with 2.4 micron thick driver material, you know, which is really we've got enough to wrap a couple of sports arenas with it now, but because 100 kilos of it goes a long way. But when you're working with stuff that's 2.4 microns thick, it's hard work. So, but the results are big payoffs, and you're seeing these increases in or improvements in materials, and the technology for using and applying the materials is really going through an exponential curve of improvement right now. And I think that's great, because when people are starting to work on digital technologies, DSP and other things, the core transducer technology will be there to really make the most of those advancements.
Thanks, Dan.
Yeah.
Nicolas?
I totally agree. I mean, I share the very same point of view. From the pro audio side, yeah, sorry, it's better now. From the pro audio side, we've seen so many things like DSP processing for speakers to fix your room problem, blah, blah, blah. If your room is not good, your room is not good. You can use tons of DSPs or whatever, you still have a room problem. The same will go for any technologies like HRTF. As Dan said, if you are already using, be it electrostatic or planar or whatever, or electrodynamic drivers that are not properly designed right from the start, then you will never get that kind of vivid sound and true sound experience at some point. And I totally agree. For us, the key point is the raw material study from the very beginning. We have a background in that field with beryllium dome as an example, or other raw materials for drivers technology, and it's always a key point to strictly reproduce the audio signal, nothing more, nothing less. If the driver itself, the mobile equipment assembly, is too heavy, you're going to lose dynamic, you're going to lose details, you're going to lose so many things. You can have the best processing whatsoever, you're going to miss things, and these things will never be reproduced. So for us, it's, I would say, the same thing, always the same battle with having the lightest possible mobile equipment, and we already achieved an interesting result. We are working on some new things, obviously, but that's pretty much the battle we are working on every day at Vocal.
Fang, why don't you give yourself a little introduction, and then the question is, where do you see headphones going over the next 3 years?
Oh, okay. So, you mean me to introduce myself?
Yeah, because you weren't here at the beginning, so go ahead and introduce
okay.
yourself and
Okay,
then answer the question.
I'm Fang from HIFIMAN, the founder and CEO. We are the planner, headphone manufacturer, as well as players. Because, okay, it's going to be a long talk, sorry. Okay. I read about the topic, email me, and fortunately, I work with Smith and several virtual 3D vendors in previous couple of years. Everybody knows about HRTF is important. HRTF is about the space informations in the sound waves. At the beginning, when I first worked with Smith in that project is not finished yet. It's not finished, but it's interesting. My experience in their office. Okay, I tried their system. It's a 5-way home theater system. They measured my ear, and then let me listen to their home theater system first, and then give me a pair of stacks. And they use their DSP to mimic their home theater system, and I cannot tell the difference. So, in other words, the stacks headphones with DSP have no difference. Have no difference from 5 speakers in their room. It's amazing. So, after that, I try to talk to everybody who can do virtual 3Ds and find out if they can do the same thing. No, they cannot. Why? I don't know. I'm not professional in virtual 3Ds. I'm not an engineer in that. But I noticed that Smith is the only vendor who scan my ears. In other words, they have to know every detail of my ear pinna structures to get the exact data. It's like real 3D. Okay, and also I also noticed that most of the virtual 3D vendors, they were using a dynamic headphones, but only Smith uses stacks. Stacks is way more expensive than a pair of Beats. And so after working with 4 or 5 different vendors, I have a feeling that the measurement in the ear is important, and the speakers or the headphones is another very, very important point. So about 2 years ago, when there was a professor from Peking University, which is the #1 in China, he wanted to work with me and test his DSP. Okay, it's a very old prototype, very prototype thing run by his PC. So he bring his PC to my office. In my office, there was a system, a very expensive system. I don't want to tell you the name, but it's very, very expensive. It might be the most expensive bookshelf speakers in the world. Okay, so that the system should not have any problem. All right. So we did the measurement in my room, and it's a 2-way system. And when we finished the measurement, right, I listened to the same music from my headphones and his program. All right. So I hear exactly the soundstage in my room. However, the signal to noise ratio is a problem. So according to my experience, it's like you have to trade off something. Either you do measurement of your ears, or you trade off the signal to noise ratio or distortion. Well, the distortion like Dolby or DTS, their distortion like 5% to get virtual 3D some stage. So yeah, so it's like the God can do everything, but we are not the God. We can only do part of the word, not 100%. That's my feeling. In addition, all right, I'm a businessman, so I always want to say my product is better, right? So when we work with that lab in Peking University, we try all different headphones in their system. And HIFIMAN planar headphones sound best in their sound stage, their space informations representing. The reason, I guess, is that planar technology can conduct more space information than the regular dynamic or moving cone speakers. You think about this. This is a piece of paper, right? The dynamic speakers is like this. So it's not a planar thing. So this is like the diaphragm, right? So the diaphragm will move back and forth in the direction that the coil, the directions, right? So in that situation, every point on this, they are not perfect or accurate enough. So, but think about the planar things. For example, we have the planar diaphragm, which is in nanograde thickness. So the coil was on the surface of the diaphragm. So when the coil moving, because the diaphragm overall is very, very light, so the coil have fully controlled the whole piece. In other words, every point on the surface of the diaphragm, they're moving is more regulated comparing to a heavy cone.
So would you say that a lot of what your work has been in recently and currently is in the is still in the tweaking and the designing and the materials of the driver, that you're spending a lot of time still getting that driver to be just right?
Yeah. My philosophy about the driver is about the diaphragm of the drivers is that do not put any extra structures which do not generating sound.
Right. I have to ask you, Nicolas, because so Focal has just recently introduced 2 high-end headphones that are, in my opinion, extraordinarily good, and they were, from what I could tell, a ground-up development. This is a clean. You started with a clean white slate, and can you tell me the role that choosing the materials, the diaphragm, or the you call it a dome materials,
Yeah.
and how? Just tell us a little bit about the dialogue that happens when you go from one material to another material.
It's to sum up the idea behind it. The goal is always the very same. We are looking for the best ratio between damping, rigidity, and the lowest possible mass, because as you said, mass does matter. This is why we did a major innovation in the dynamic technology that consisted in having the very first voice coil ever without any former. So there we save huge amount of extra mass, because the former only, when we removed that one, we divided the mass of the mobile equipment by 2. So it was kind of a huge thing for us. Plus the rigidity is very important, as you said, because you must maintain a perfect piston functioning. If not, you're gonna face problems. Could be distortion due to the cone which is not rigid enough. Also, if the mass of everything is not 100% perfect, you can face some rocking mode in the same time. So here the manufacturing process is very, very difficult. I can tell you we have more than 35 years of knowledge in terms of developing and manufacturing tweeters, mid-range, sub-bass driver in France. However, we didn't think when we started that project we would need such an amount of time to develop the entire manufacturing process, because that requires a lot of in-depth study of the glue, obviously, because the mass of glue does matter, as you may imagine. Here you discussed about, you mentioned the mass. It was so important for us to achieve that mass. I mean, for Utopia as an example, the mobile mass equipment is 135 milligrams. So for an electrodynamic driver, it's almost nothing. There, you have to, in the meantime, make sure that all the components surround to the dome, voice coil to the dome, will be 100% stable while using the lowest possible amount of glue, because if not, you're gonna increase the weight and then you're gonna decrease the performance of a driver, especially the frequency response in the high frequencies. So that was basically one of the core story. And then, as we have now more than almost 15 years of knowledge in terms of forming beryllium sheets, which is a very interesting raw material. I mean, you only have 2 raw materials in the world able to scratch glass. I'm sure you know the first one. Yes. The other is beryllium. So that gives an idea of the rigidity index of that raw materials by itself. And the damping of it is impressive. So for us, it was obviously mandatory to use that raw material. But there we ask, compared to the tweeters we manufacture since 15 years, not only to produce frequency response from 2K up to 40K, but frequency response from 5 Hertz up to 50K. So that was the core challenge of it. Yeah.
And I'll go back to Dan. It seems for the moment we're on the topic of making current headphones really perform as best they can. Dan, can you tell us a little bit about your experience of the flow baffle? Dan's worked a lot on driver diaphragms and planar magnetic headphones, but even just the acoustics around the driver. Just give us a blurb on the flow.
So last year we came out with our Ether headphones, which had our first in-house design driver, and we'd spent pretty much since I started the company 4.5 years ago, have been developing that and using all the work we were doing to fund that project. And we released that headphone and then dove into our next project, which was an electrostat. And working on the electrostatic headphone, I came to the conclusion that there was more at play in the difference in resolution between planars and electrostats than you could account for simply by mass of the moving mass of the driver. And so we started researching and looking at the motor structures around the driver and concluded that the real issue that was limiting the planars was not getting the driver lighter, it was getting the air through the motor more cleanly. Because in planar magnetics, in an electrostat you have a flat baffle with perforations. You might have, there are screens, there are other ways to do it, but it's generally a very easy load and very good load for the driver. You have a moving flat diaphragm that's forcing air through a flat surface that's essentially perforated. And that will give you very clean behavior. It's as close to ideal as you can get. Planar magnetics have a different issue, which is that you have to move the air through an array of magnets. And those are comprised of bar magnets or magnets and trays, which have hard right angles. And no matter what you do, that injects a little bit of entropy into the signal. And what we figured out was that if we filled the space between the magnets, or between the magnets and trays, and then perforated that, what we would actually be doing is making a motor structure that now looked and behaved like like an electrostat's stator. It's a flat surface with holes going through it. So we've replaced vertical or right-angled edges with perforations. And that allowed us to get a much more detailed presentation out of the driver, reduced entropy, reduced distortion. Basically, you get a lot more micro details, more dynamics, and a smoother delivery. So that actually was a really neat project because it kind of was an exercise in you start a new technology and you don't realize that that's actually going to benefit your other products. But you know, it was really a worthwhile effort. It makes me want to look at other, you know, like dynamics and stuff now too, because it's like, who knows what we're going to learn that may play into the electrostats and planars. So I think that there's tons of interesting stuff that we just don't know yet that we can use to improve the performance of our drivers, and it's going to be a lot of interesting work over the next couple of years, because I think everybody's been moving the bar so quickly. You know, we're all having to look in new places to challenge our assumptions and see what we can do to get better.
So I have to say, one of the themes that you can take away so far here is that there's still a lot of work being done really directly on the headphones themselves to make good motors and good transducers. But I think there's a whole lot of more stuff that may be coming down the way. And one thing I want to toggle Jude on just briefly is, you mentioned that the people in this room and the audiophiles, the 2-channel and so on and so forth. Would you say that there's a demographic difference between traditional audiophiles that would read Stereophile magazine and the headfires out there, and what their willingness to accept new things are? You know, do you think that there's
No, I think that well, it's fair to say that headfires are on average younger than the audience that we have here. I'm 46 years old. When I go to a traditional 2-channel hi-fi show, I feel still a bit young. Mm-hmm. And then when I go to a head-fi show, I feel, well, old, you know, so, because our can jams that we do, so we do this can jam in RMAF, but we have independent can jams as well, which are just can jams, just headphone audio. And the audiences there are younger. But as far as willingness to accept, I don't know. You know, there's something that happens when somebody puts on an amazing pair of headphones for the first time. There really is, right? Even in this market. And I've had a lot of comments from some of the society, the Audio Society members. One of them, I haven't seen him though in a couple of years. Mark Madrude. Anybody know him? Anyway, so Mark, I remember he came to me the first can jam at RMAF we did. I think we only had a few exhibitors and 12,000 square feet of space. So we had like zip codes between everybody. But anyways, but he came in and nobody was really coming in. It was dead. And Mark comes in, he was from the Audio Society, and he just said, this is like the most exciting thing I've seen, you know, and heard in years. I'm going to be back tomorrow. I'll bring my own headphones so I can listen to different things. And but I've had a lot of that. So I think there's an age difference, yes, but a willingness to accept it seems pretty universal, because once you put it on and you hear...
No, but I mean a willingness to accept things that traditional audiophiles might not accept. For example, DSP and EQ and cross-feed circuits and Bluetooth speakers and to be enthusiastic about a good Bluetooth speaker. And
well, the headfires are pretty kind of hardcore audiophiles, just of a different type, right? Mm-hmm. So I think they're probably going to be a bit resistant to some of that technology, certainly for music, as much as any of the audiophiles are with speakers. But yet we readily adopt it for other things like movies, right? I mean, we go to a movie. I want to see a movie with surround sound. But yeah.
All right, so I'm gonna break in here and try to stir the pot a little bit. And so I went to this conference with Jude. We sat in a 95-degree room at 92% humidity for 3 days and listened to high-level engineering papers. But I hardly saw anybody fall asleep. And the reason why is because the work that's being done is very, very complex and takes in a lot of space. And what it boils down to, you heard the word HRTF, head-related transfer function. That's the series of a series of plots of the response at the eardrum from sound coming from different angles. The other 3-letter acronyms are BRI, binaural room impulse response, which is the way the room sounds to your ears. And then head-related impulse response, HRIR. But there was a lot of acronyms in those papers. And the bottom line gist of it is this, and I'll go just zoom past everything and go right to the bottom line. Maybe 5 years from now or so, you'll see a Beats headphone that virtualizes audio. It has a little drop-down visor that comes in front, like the Microsoft HoloLens.
Yeah, I think it's the HoloLens.
HoloLens or something like that. And what they're trying to create is mixed reality. So when I go to Japan and I drop this HoloLens down and I look at a sign, it will be in English. And when I talk to somebody, I'll go, where's the train to Yamamoto? And the headphones will go blah, 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 and say it in Japanese. And then the person will answer in Japanese, but I'll hear it in English. And put another way, little kids will hear the Pokemons running in the bushes and try to find them. And when they see them, they'll catch glimpses of them. And then the Pokemons will run across the street, and the kids will run after them, and the cars are going to hit them. Or something like that. But the bottom line is that...
progress.
Yeah. But there are some great things about this progress. Blind people will be able to say, I need to go to the drugstore, and they'll follow a virtual sonic crumb trail that's auditory, and they can be able to follow it along. Autonomous driver technologies will allow cameras in the headphones that will give blind people audio warnings. There's somebody in front of you, the light is red, whatever it happens to be. So what we're going to see 10 or 15 years, 10 years from now, I guess, is a decent number, are headphones with a lot of signal processing in it. One of the big problems is you can't solve the head-related transfer function problem and sound sources moving around as you move your head for 11 channels at 1644 on this iPhone or in this phone.
In 5 years, though?
There's just maybe in 5 years. Yeah. But the better thing is to put the load in the headphones and have the headphones do the processing themselves.
Would you mind if I jump in and ask a question about that?
Sure.
Because, from a economics perspective, why would you want to do that? Because then every transducer has to carry the load of all the DSP, as opposed to having kind of the core computational device distributing it across all the transducers.
Because maybe I don't even want that anywhere near me.
Well, that's a good point too.
Right. So maybe it's all in here. But that is really tricky. And Paul says he thinks he knows a number of these challenges. Why don't you rattle off a few of the challenges to get sound to sound like it's coming from outside your head?
Okay, well, any of you who have a noise canceling headphone, some of these have a feature where you can hit the monitor button. And what that does is it turns the two external feed-forward microphones on so that you can actually hear what's happening outside. If you're on a plane and the stewardess comes up and she asks you something you want to be able to hear, and on our headphone you can push a button and you can hear what she's saying. And I've done a lot of kind of experimenting, and just to be able to hear the binaural recording really gives you some virtualization. So to include the head transfer function in its great detail that you can do may not be absolutely necessary to create some illusions that are very simple to do in processing.
Mm-hmm.
And I believe that, and I'm doing some experimentation on it. I believe, let me just go back. I'm really into the science of this as much as I am into the execution of it. And the science tells me that, you can measure what things are important and what things aren't important in the human, processing that we use to experience the world around us. Our brains are our devices, our ears and our eyes are extremely astute, and our brain is extremely good at processing. But what elements of that information does the brain really use the most? And that's the challenge. I believe, based on when you're born, if you watch a baby and a baby hears a sound when it's an infant, they respond, but they don't know where that's coming from. They learn that because they have the tools and the brain to do that. I believe that if you give the individual some tracking so that when he moves his head, it responds accordingly based on the time arrivals based on both ears, you can teach people how to do that. And that is to take the sound outside the head. And as was mentioned earlier, Smith has an ability to emulate that by measuring the ears and all that sort of thing.
It does an actual measurement, yeah.
But is it practical? And
No.
at what degree can we accept that? And I think if you incorporate something that is sort of a training session, you know, have a PC and there's certain audible cues, or maybe a big screen TV and certain audible cues that you can learn. I go back to the time when, I don't know if any of you know who Dr. Floyd Tyll is, but he's well known in the audio industry as, you know, kind of set the stage for what makes good loudspeakers sound good. His PhD was done on sound localization. And one of the experiments that he did in his PhD was to get a better understanding of people's ability to localize sounds.
Mm-hmm.
So he put individuals in the anechoic chamber, and he had several loudspeaker sources in front of them, which they couldn't see. So they were in a dead environment, trying to tell, you know, that's the far right, that's at this degree, that's at this degree, when they hear sounds. And you know that one of the experiments he did, he was able to fool the individuals by the sequence of sounds that he created and the patterns that he created. That's at one point, people would think when the sound came from that side, it was coming from that side. And that was a learnt process. And I believe that might be a shortcut to creating virtual reality.
There were one of the papers presented at the conference was a paper. A lot of the papers presented at the conference had to do with how to make the problem simpler.
Yeah.
And one of the papers showed that they could take the binaural room impulse response, in other words, the sound of the room itself, and cut off the reverberant tail, because that tail is long, and the length of that BRIR is the problem. And so they let the tail run out a certain point, and then they just looked at the long end of the tail, and they made an estimation of what it was, and then they just filled it in with noise, basically. And that it was indistinguishable in subjective tests. So I have a question for you, Nicolas. If the world goes in this direction, when the world goes in this direction, where headphones will become smart headphones, do you see Focal participating in that, or do you see no? We would stay in the analog space, so to speak.
We already did that. I mean, we are talking about headphones, so you are not aware of that, but we already did some partnerships with companies like Gold Moon in hi-fi. They are famous for constant phase and all that stuff. So yes, we are already working on that with some partners and so on. Yeah.
So smart headphones, so to speak.
Yeah. But as I told at the very beginning, that doesn't replace very good bits planar magnetic, electrostatics, or electrodynamic drivers, because you can have tons of things, processing and so on. If you lose something because of the poor quality of the driver, it's lost.
Yeah.
So even the best DSP will never get it.
We're an audiophile show, right? And I still think that with the audience that we're talking about here, I still insist that there are going to be the thing that we're talking about with all this virtualization is going to be huge. By the way, the market is going to be ginormous. Huge. But I still think we're going to differentiate our experience. So a couple of points brought up. Tyll saying smart headphones. I don't think we are going to be using smart headphones to listen to music. Fang brought up earlier that Smith does amazing processing, right? It's actually the most convincing. But in order to do it, you need a very resolving headphone. They're using stacks. Actually, they're also now using Sennheiser HD800 S or 800s. And so you do need the resolution. A smart headphone, let's look at OSIC, right? So there is a smart headphone that's coming out. It's a 4-driver, does beam forming. I ordered one. And the reality is, I mean, I'm probably not going to listen to music through it, but will I be doing shoot-em-ups and gaming through it? Yeah, probably. Will I watch movies through it? But I don't think. And so I had an interesting conversation with Vlad Savov from The Verge, who has a pretty interesting perspective on things, because he's a general tech writer, but he reviews hi-fi stuff. And he said, you know what's amazing about this room? We were in CanJam, London. He said, what's amazing about this room is if you look at the world, you look at mobile phones, right? And if you want to make a really good mobile phone, you need scale, lots of scale, right? Because there's so much processing, so many sensors, so many proprietary things. He said, I think the camera department at Apple alone is like hundreds of people, right, just to get the camera right. And he said, so you can't make money, you need so much money, so much scale to make a good phone. He goes, but this is crazy because no matter how much there is in terms of making like a phone and how much you need that, for hi-fi, for some reason in this room, we're listening to the best headphones in the world right in here, right? And it's guys, it's companies that are not huge companies, but the big guys will never beat these guys in terms of just raw fidelity of a driver, right? They're not going to beat Focal, they're not going to beat MrSpeakers, they're not going to be, but now there's DSP, there's that aspect of it, but it still requires, as we're talking about, a good driver, right, to do it. And so I think that again, because I'm, with the audience here, that there's still going to be a dichotomy between how we interface with this processing and our music. Because I think largely what we're talking about around here is music. I'm sure there's some video stuff going on around here, but I think it's music. So I think the processing is going to be huge. There's no question about it. But I just don't think it's going to be, I just don't think it's going to have as much of an effect on music listening for audiophiles as maybe some of this conversation suggests.
I'll make an analogous observation, which is if you look at the way DSP has evolved in home audio and home theater, it's all in the control devices. It's not in the playback transducers. And there's a good reason for it. Because if you put it in the transducers, again, it goes down to the cost and complexity of what you've now added to the transducer. And so you don't buy surround sound speakers that have Audazy or whatever, surround room processing in it. It's all in the receiver or the surround processor. Yeah. And whether it's a phone or a DAC amp, it seems to me that the effective way to use that is always to have the processing in the source of the electronics. Now, there will be applications where that may be cost reduced and shrunk into headphones, and
portable,
that might be
right?
like awesome for gaming or your types of on the street.
Portable, right?
Yeah. But that's not going to be, the performance sound or performance audio playback, and it will serve different purposes, and that's the kind of stuff you can probably cram down into specialized DSPs.
I'm going to have to stop us here because we're completely out of time. We're actually over.
No, we're not. We
What?
have 15 more minutes.
I thought it was done at 2:30.
It says 2:45.
Okay, good. Wow.
That went fast.
Good, go ahead.
Just getting back to something that Jude was referring to, and that is the lion's share of headphone displays at this show are using the best diaphragms and the best sound we can get outside of all the things we've talked about with regard to head transfer function and DSP control. And one of the challenges I think, and Tyll and I were talking about this before the seminar or before the panel discussion, and that is when you look at a typical on-ear headphone that might use a 40 millimeter driver, if you look at the dimensions and then the wavelengths related to those dimensions of the cavity that the driver is in and the size of the driver, you immediately realize that there's a lot of chaos going to happen around 5 kilohertz to 10 kilohertz, because those are the dimensions that the driver and the cavity that the headphone is in. And one of the things that I'm sure you've realized with measuring headphones is that above 5 kilohertz, it's just a mess. Like things don't look like they do on a normal loudspeaker. And it has to do with the physical limitations of what you're doing by putting this thing over your ear creates a cavity. And I'm sure anyone who's been doing headphone designs, the ear cup and the ear pad and how it absorbs and all that sort of stuff is huge, not just the driver.
Yeah.
So I think there's a lot of room for improvement in that area.
Yeah.
And that's the focus that I've worked on. And I don't know if I've mentioned to you, Tyll, I did a paper on recreating an ear canal. There was a study we did to try and emulate. We took actually a scan of an ear canal of 14 human cadavers. And so they range in size from maybe just over an inch long, and some of them are almost 2 inches long. And the diameters are quite different. And we're in the process of modeling and finding a very good measurement system based on real human ear canals that can help us develop and design better environments, headphones, and of course that includes the driver, but also the environment that the headphone or the ear is in when you put your headphone on. So I think there's a lot of work to be done in that area outside of all of the technology that we're talking about as well. And planar speakers, like when you have a planar speaker and the whole thing is a piston, when the wavelength becomes smaller than the size of the diaphragm, it starts to cancel and you get all kinds of constructive and destructive interference. And it doesn't matter how small it is, provided it's larger than 1/2 inch, it's going to start to affect the bandwidth that we can hear, which is up to 20 kilohertz. 20 kilohertz has a wavelength of about 1/2 inch. So at 2 inches, the wavelength is at 5 kilohertz. So between 5 and 20 kilohertz, all hell breaks loose when you put a headphone on your ear. And
So-
that's a challenge.
So I want to give an opportunity for questions, but I'm going to mention one more thing. I totally agree with Jude, actually, that there's going to be two types of headphones out there. There's going to be smart headphones, and then there's going to be, well, let's call them high-fidelity headphones. But I want to imagine, if you will, these, like people have the little one-ear Bluetooth things, but having them in both ears, replaceable shells so you can make them different colors and whatnot. They now have noise canceling where it cancels noise that is spatially incoherent, but does not cancel noise that is spatially coherent. So in other words, you could sit at a table with 3 or 4 other people, and because their source is very close to you, the noise canceller will allow it through. But all the diffuse noise in the background, it can cancel. And eventually, it's going to be smarter than that. I think AKG had a prototype, and I'm not sure who it was. But it would recognize your name. So if you were in a bar and somebody yelled, "Tyll, your table is ready," you'd hear that through the noise canceling. Okay, so a lot of this technology is actually going to, for smart headphones, is going to come out of the hearing aid world, and the hearing aid people, hearing aid assisted listening devices, and your average portable walk-around pair of headphones there's going to be a continuum of these things, and a lot of it's going to be about smart noise canceling and additional noise. And maybe one of the hardest challenges of all is being able to put a pair of headphones on and hearing the ambient noise just like you normally would. So you put the headphones on, but it doesn't sound like you have anything in your ears. That may be one of the hardest challenges of it all. Anyway, this is a very, very complicated subject. Questions? Yeah.
You mentioned the ear canal, and there are resonances there too, very bothersome resonances that certain headphones try to notch out a band of frequencies where that might be bothersome. Now, you mentioned such a variation, though, in those sizes.
Yeah, and the
What
thing is,
frequency band are we talking about?
when it comes to the resonance of the ear canal, it tends to be around 3 kilohertz, 3 to 4 kilohertz. And it depends on the length that frequency will change. And then when you put an in-ear in it, that frequency doubles. So if you're doing
smaller cavity.
Well, now it's instead of a half wavelength phenomenon, it's a quarter wavelength phenomenon.
Right.
So the frequency doubles. So when you close the ear canal and you don't take into account the fact that when the ear is open, a normal person's resonance is around 3 kilohertz, and then you close it and it goes up to 6 kilohertz, that doesn't sound right when you put an in-ear in. And that's why, when I do an in-ear, I make sure that the resonance or the response when the ear canal is closed is what it would be if the ear canal was open. And I pay attention to that sort of thing. And most companies would do that as well. I mean, that's when it sounds good, because it's more normal. We are used to hearing that resonance in our ear canal. In fact, it's probably nature has designed it that way as a survival technique, because our ears are very efficient at the 3 kilohertz region. Like, we don't need much sound to be able to hear those twigs crunching in the forest and the leaves. That's the frequency range where all that stuff occurs.
Now, the 800 model, HD800, versus the S. Weren't they trying to suppress a 6K?
That was just a little resonance in the driver. It was about a 6K resonance.
Nothing to do with it.
No, it was a resonance in the ear cup, from my understanding. Other questions? Jamie?
For the manufacturers, is the removal of the headphone jack on phones a concern or an opportunity?
Anybody want to comment on the missing headphone jack?
Well, I think that from the perspective of a high-end headphone, you can use a high-end headphone on your phone, and people do that. You know, like I'll do it when I'm doing the dishes, and I put on my headphone and I'll stick my phone in the pocket. But, you know, the iOS devices, you can still get a 3.5 adapter. It comes with it, and you can still use your phone. But for the type of work that we do, people buy DAC amps to go with their devices, and you know, the Chord Mojos and stuff like that. And that's because we're catering to people who are looking for high performance audio. And the phones are not made for that. Phones are made for convenience. You know, and they're a generalized tool that tries to do everything. And so it will do audio okay, but it will never do it beautifully. So it's not something that is going to affect our market for what we do. But, you know, IEM makers and stuff probably have a very different perspective on that.
Fang, are you in the process of making a Bluetooth headphone?
Well,
Well,
when Jeremy asked that question, actually, I'm laughing because I don't think it's gonna affect our business in the high end. You know, we are manufacturing expensive thousands of dollars headphones, so.
but you make low cost headphones too.
I do.
Yeah.
Yeah. We just submit something to Apple. Well, I'm finger crossed right now. So we have to deal with them. But I personally don't think Apple did the right thing in the sound quality. The reason is that Apple iPhone 5, iPhone 6, their sound quality is actually not bad. Mm-hmm. I did a big comparison that to there's. Okay, that manufacturer is not here. All right. Okay, I did a big comparison. Use the iPhone 6 versus a player. Okay, and that player is more expensive than iPhone 6, and I think iPhone 6 sounds better. I did double blind listening. I know this kind of topic was forbidden in HIFIMAN, but.
We have a
True,
forum
right?
for that. We have a forum for it. Sound
Yeah.
science. Yeah.
Okay. So basically, I have a feeling that Apple is actually they still use the Cyrus stack chip in the iPhone, but the new thing in the headphone output, they force people to use their Apple's custom-made chip. And everything in one chip, like the DAC, the filters, the amplifiers, everything in one solutions. That sound quality is not that good. So from my point of view, I think this is an opportunity for us, right? We are submitting some documents to them, and we will try to improve that. Because we can, if they allow us to redo the DAC part and the filter part, and then we're gonna sound better.
Nicolas, do you think you guys are going to be making something with a lightning cable on it, or wireless? Or
We are not
you gonna
electronic
respond?
manufacturer, first of all, you know.
Ah,
No, I think it's a very good opportunity for the end user, I would say, because first of all, so I have the previous one, but two limits: the DAC quality for me and the output. The output of it is so limited that when you crank these tiny bit too much, you get tons of distortion. And I tend to use that when I use some headphones. I use an external DAC, so that's what I do.
what do you think the response has been in general in the forums
To what?
to the missing iPhone?
I mean, they've been pretty. I mean, largely negative about it. I mean, nobody wants to lose the headphone jack. I mean, I have the new one. I admit it. I've
got one coming.
You got one coming. And honestly, I think again, now we run into another difference, right? The difference between the general consumer and the audiophile, and we're the audiophiles in here. And we have the problem of buying too many headphones. So for the general consumer who maybe has one, maybe two headphones they use, just keep the adapter on the end of it. I mean, but honestly, the sound to me is what I'd expect from my phone.
Do you think it might drive more consumers to consider an outboard amplifier option? No?
Nope.
They're just going to use the little dongle or a wireless headphone.
Yeah, but
more likely a wireless headphone.
But again, there's always a fringe, right? So the bigger something gets, the bigger the fringe gets. So the fringe is gonna. There'll be more people finding things like that, but it's still not going to be like, no. I mean, you're still not. My mom is not going to use a Dragonfly. I assure you.
Well, our reaction to the situation with Apple is actually we're bringing out 2 new headphones. Replacement for the M4U2, which will be Bluetooth, and we're also producing a new NAD headphone, which currently is the HP50, and it'll be an HP70 with Bluetooth. But we will still have the connector, so you have the option of connecting it either through USB on your computer, or wirelessly Bluetooth, or with a 3.5 millimeter jack. So we've kind of thought ahead in trying to accommodate all the listening habits of people. And of course, both these headphones are also noise canceling.
Well, I could tell you folks for absolutely sure, we haven't even barely begun to scratch the surface of what's going on in the world of headphones and how it's going to be changing. So I'd encourage you all to stay tuned, watch what these guys are doing, read interfidelity.com, participate on headfi.com if you want to dig into it a little more, and enjoy your headphones, because they certainly have gotten a lot better over the last few years. All right. Thank you very much, guys. Thank you.